Okay, this next section we are continuing with parallelograms, but today you're going to see a special type of parallelogram. And that is called the rhombus. Right? But it's still going to hold true some of the same characteristics that we know for parallelograms. It's still going to hold those characteristics true, but it's also going to have its own unique characteristics. So let's look at just the regular parallelograms, and right now I'll talk about what's a little bit more specific about a rhombus. Okay, so this is what I want you to review or recall from just parallelograms. Just from parallelograms, I want you to just remember this. Okay, remember, let's say we have a parallelogram that is looking like this. Remember a parallelogram, remember the top and the bottom side are parallel, the left and the right are parallel. Okay, but remember the angles? Like if this is 100, then you should be able to find all the other ones. This is one of them that's still going to hold true. Opposite angles are congruent. This is still going to be true. Well, what does that mean? What does that mean? Well, if this is 100, guess what? These are the ones that are opposite, right? Like the ones that are across or diagonal from each other. This one's 100. This is 100. That's still going to be true. And what else is going to be true? That, remember these same side ones that are same side of a line? They add up to what? They add up to 180, right? So same side. And, you know, when we say they add up to 180, remember when you hear this, when you have the 180 degrees, remember they can get fancy and say, okay, they're supplementary. That's the vocabulary for adding up to 180, right? So this is 100, this is 100, okay, I'm good with that. That doesn't mean these are 100, but if I know this one, I should be able to know that these two add up to 180. Well, if that's 100, this one has to be 80. And then we look at these, right? These will be the same, these opposite angles. Okay, that's going to be true. That's pretty easy, right? And then it's really obvious here that the top is only congruent with the bottom, right? Because this size and this are the same. So this one's congruent with this, but we'll talk about the sides later. So now so for now, just remember this part for parallelograms about the angles. Now let's get into the rhombus. Okay, the rhombus or the rhombus. Rhombus. Here's what is true about for all rhombus, which actually in plural it's rhombi, but we're just going to say rhombus. Here are the characteristics of a rhombus. First of all, what does it look like? Well, you know how a parallelogram kind of looks like you know how a parallelogram you can kind of say, oh, it looks like a rectangle that's been like kind of tilted over. You kind of just like the angles got tilted over. It got kind of like it's just leaning that way, right? This one looks like a rectangle, and if I lean it, it looks like a parallelogram. A rhombus is almost like if you take a square, because it has several properties of a square, right? A rhombus is almost like if you take a square, but it can't be a square because I know the square has all the angles 90. I know for a square, this is a square. And what else is true? I know the square is like the most perfect, right? All the sides are the same, right? A square, all the sides are the same. That is not true for parallelograms, right? The top is congruent with the bottom, the left is congruent with the right. But this is a square. This is a square, but a rhombus is almost like if you take a square, and a rhombus will have all sides congruent like a square, But the only difference is the angle. See, once I get this square and I kind of tilt it over like this, the sides are still the same. Let me make it look the same size. Something like this, right? Almost like if I take a square and I just kind of lean it over, these angles are not 90 anymore. The angles are not 90 anymore, but the sides are still what? For a rhombus, it's like a square that's kind of been leaning over. So the sides are congruent. That's a main thing right there. Let's talk about that. The sides are congruent. Or all sides congruent. So let me talk about that for this video, and then I'm going to go to the second video, right? So a rhombus can look like that. It looks like a square leaning over. Or sometimes people say a rhombus looks like what? Like a diamond, right? Like a kind of like a diamond. Not yet. He's not here yet. It's almost like a diamond, and remember all the... Oh, then they just gave her that phone call home that day. All right. So it looks like it still looks like a square, right? That's been like, it looks like this square that's kind of been like rotated like this. But again, I'm telling you, the angles are not 90. Because if the angles are 90, then it's a square. The angles will be like, maybe this is like 92. And if this one's 92, this is 92. Something like that. Right? But they're not 90. Once they're 90, then it's a square. But that's why they're so close to each other, a rhombus. And remember, all the sides are the same. And then what is also true? Well, again, remember, if this one's 92, this one's 92. But remember, they still hold this true. If I know this one, I know this one. But then these ones on the side, they add up to 180. I'll come back to the angles, but I want to talk about the sides. So yeah, it looks like a diamond or it looks like a square because all the sides are congruent, but the angles are not 90. Maybe it's like 92, 92, so this one would have to be what, like 88? Right, because 92 plus 88 is equal to 180. So if I know this one, I know this one. If I know this one, then you should be able to get this one. These add up to 180. And then these are what? Opposite angles are congruent. That's still true because it's still a parallelogram. It's still true that what? This side and this side are parallel. And it's also true that this side is also parallel with this side. Okay, so let's talk about right now all sides being congruent. Well, that's going to be easy. So if you have a problem where you have a rhombus, right, let's say they say quadrilateral ABCD is a rhombus. If you have something like this, that means you have, well, let me just make it look like, again, like a square, right? I know all the sides need to look like they're the same size. I hope they kind of look like they're all the same size. Okay, they're all the same length, right? They're congruent. This is a rhombus. We're just talking about the sides right now. So if I have, let me call this problem 1A and let me call this 1B. Let me put another one over here real quick. Okay. I know all the sides are congruent. What is the difference between if you see a problem that says 5x plus 3 and 13 like this, and you got 5x plus 3 and 13 like this? What is the difference? Well, remember, for a rhombus, it doesn't matter. It doesn't matter. Well, everything matters, but I know all the sides are congruent. Not only is the top congruent to the bottom, but all the sides are congruent, right? All of them, right? So let's come over here. Let me draw a separate one over here. What does that mean? If this one's 8, they're all 8, right? They're all 8. So when you have expressions like this, they don't have to be necessarily opposite sides. any side you can put equal to any other side because they're all congruent. So here your equation would be 5x plus 3 is equal to 13, right? This one's kind of easy to see, right? The top with the bottom. And then you solve it, minus 3, so that'll be 5x equals 10. You're going to get x equals 2, right? But then what if it's this way? Well, remember I just said all the sides are congruent. So it doesn't matter if it's the top with the bottom or if it's the... You can put any two sides equal to each other because they're all congruent to each other. So here it's kind of easy to see, but even if you go this way, it's a rhombus. All the sides are congruent. You can still put 5x plus 3 equal to what? Equal to 13. Right? Because all the sides are congruent. Okay. And then you solve it, and we're going to get the same answer, right? 5x equals, take away 3, we're going to get 5x equals 10. We're going to get x equals what? X equals 2. Yeah? Okay, so this takes care of the sides. This takes care of the first video. And then the next video, the next two videos are the ones that are going to talk about the angles. But it's just as easy. Okay? Good job on this one. Here's the first video done.